Question number 3 says that a cistern internally measuring 150 centimeters times 120 centimeters times 110 centimeters has 1,29,600 centimeter cube of water in it. Now porous bricks are placed inside the water until the cistern is full to the brim. Each brick absorbs 1/17 of its own volume of water. How many bricks can be put in without overflowing the water? Each brick being 22.5 centimeters times 7.5 centimeters times 6.5 centimeters. So this is how one cistern will look like, and these are the dimensions which are highlighted in the figure. We can take it as length, breadth and the height, and this is the brick that we have with the highlighted dimensions, and we can take them as L1, which is length 1, B1 which is breadth 1, and height as H1, because we've already used the notations of LBH for the cistern. Now what we know from the question is that the cistern has water which is 1,29,600 centimeter cube in volume. So there will be some space left for some more water to come in. So what we do is we place a certain number of bricks inside this cistern. So now the bricks are not solid bricks, but they are porous bricks. So what they'll do is they'll absorb some amount of water which is already present inside the cistern, and hence will create more space for anything to come inside the cistern. So to start with, what we'll do is we'll find out the volume of the cistern. So as it's a cuboid, we can make use of the formula LBH. So we'll multiply 150 times 120 times 110, and we'll get it as 198 followed by 4 zeros centimeter cube. This is the volume of the cistern that we have. The next thing that we do is we'll have to find out what is the volume which is left to be filled in the cistern. Now because we know this is the total volume of the cistern which we have just now found out, but it already has some amount of water inside the cistern. So what is the left out volume in the cistern? So that can be calculated as we can write the volume of the cistern, the total volume of it, minus the volume of water present in it. So that will give us the volume which is left in the cistern to be filled, and that is 1850400 centimeter cube. Now this is the volume that we can fill with something. So what we are doing is we are placing a certain number of porous bricks inside the cistern. So what we can say is let n number of porous bricks be placed in the cistern. So we'll have to find out the volume of n such bricks. We do not know what exactly is this n, what is the value of n, and that is what we have to find out. So its volume will be n times the volume of one brick, which can be found by making use of the formula of finding the volume of a cuboid, which is LBH. So we'll be making use of the dimensions there, 22.5 times 7.5 times 6.5, and that will give us the answer as 1096.875 n centimeter cube of volume, where n represents the number of porous bricks that were placed inside the cistern. Now going next, what we'll have to do is we'll have to find out how much of volume which was already present inside the cistern, that is the volume of water which is already present inside the cistern, will get absorbed by the bricks. So we'll do that. So we know that as each brick absorbs 1/17 of its own volume, therefore the volume absorbed by these bricks will be, we'll write it as n by 17, because n number of bricks we have and each brick absorbs 1/17 of its own volume. So that will be 1096.875. So the total volume that is left with us will be 1850400 plus n by 17 times 1096, that is 1096.875, and that must be equal to the volume of the n bricks. Now, rearranging the terms and simplifying will get the equation as 1850400 to be equal to 16n by 17 times 1096.875 as the equation. So on again rearranging and simplifying, we'll get the value of n as 1792.41. So therefore the number of bricks will be 1792, keeping it as a whole number, and that is how we solve this problem.
To learn more about how QMath can help you crack school and board exams, explore QMath Leap, a live online classroom program run by highly experienced and committed teachers.